Welcome back. Today we'll be talking about control flow. Now, control flow is the decision-making engine of your code. Let us think of control flow as the way your car knows when to stop, when to go, or when to turn. Now, just like driving, coding involves decision and loops that keep the program running smoothly. So buckle up, let's dive into the world of control flow. The first control flow we want to look at is the if-else statement. Now imagine you're driving and your car comes to a traffic light. Your car needs to decide, should I stop or should I go or should I slow down? Now let's see how this works in the code, right? So we have a variable here that is of traffic light. Let's assume this is your traffic light, right? And then you're driving and you come across or you come close to the traffic light. Okay, so this is saying, what is my traffic light color at the moment? It says, if my traffic light is equal ignore case. Now, why I'm using ignore case is just assume I'm putting this in all capital letter, right? I'm still going to match the letters that I have here. That's why I'm using equals ignore case. We could just use equals if we are sure that they're going to be the same case type, right? So here it's saying if the traffic light is equal to red, then stop the car. Else, if it is equal to yellow, slow down and prepare to stop. Else, if it is equals to green, go, go, go. But if it is not red, if it is not yellow, and it is not green, then it's an unknown light, be cautious. Let us see how this works, right? So right now, our traffic light is in red, so it should make a decision to stop the car. All right, so let us run that. Now it says stop the car. In the same vein, if we change this to green, let's assume I'm putting it in all capital letters, right? Green. But because I already have equals ignore case, it's not going to, it's going to ignore the cases and just match the text. All right, let's do that. There we are. We have go, go, go. Another control flow is the switch case. Now the switch case acts almost the same thing as the if-else statement. Let's just look at it using the same code we wrote earlier on about the green light, the traffic light, and the yellow light, right? Now in this case, we're using a switch case to do the same thing, right? Now here we have the traffic light as the variable, and in this case we're looking at the case of this traffic light, and then we're saying, okay, if the case of this traffic light is green, just print out go, go. If the case is red, print out stop the car, and if the case is yellow, just slow down and prepare to stop. But if it is not any of this, you print out unknown light, be cautious, which is the same thing we did from earlier on with the if statement. Okay, there is no way for me to do an equals ignore case just like the same way I did in the if statement. That's one downside with this one, but there are scenarios where you will use if statement if you want. All right, let's just test it out and see what it looks like, right? So in this case, our traffic light is in the red color, so we expect it to give us a stop, right? So let's just run that and see. Good. We have stop the car. Okay, so let's change this to yellow, and we should get slow down and prepare to stop. Okay, so good. Now we have yellow, which is none of this, right? That's a good case to test, right? So which means it is unknown light because this is not yellow. But now let's now put it to yellow. Slow down and prepare to stop. Another type of control flow we want to look at is the for loop. There are two different kinds of for loop. There is the classic for loop, which we're using today, and the enhanced for loop. Now, depending on what you're doing and depending on your case, you probably want to use any of them. But in my case, because I'm doing accounting and I'm working with indexing, definitely I want to use the classic for loop. But when you're dealing with iterations, you probably want to deal with enhanced for loop. So let us look at what for loop does. So in this case, just imagine you're driving your car, right? And then the car goes at the maximum speed of 100 kilometers per hour, for example, right? And we're saying that, okay, for every speed we go, as we increase our speed, we're going on a 10. So this is what this is saying. We're starting from zero. We're starting our car from zero. We're just starting our car. And as we go, we have a maximum speed of 100. And then as we go, we increase by 10. This is what this is doing. So at the end of it, when you get into, say, 10, for example, it prints out 10. Current speed is 10 kilometers per hour. When you get a 20, you print out current speed is 20 kilometers per hour. And when you're done with the maximum speed, which is the 100, and it tells you, okay, you've reached the maximum speed. So this line is for integer, which is also one of our key words. Integer speed, we're declaring an integer speed is equals to 0, which is our starting point. And speed is less or equal to the maximum speed, which means we are either going to be less or equal to 100. We can never be above 100, right? And speed plus or equal to 10. So for every number or every integer we get to, we add 10 to it. So let's just see what this brings out for us. Let's run this. All right, there you go. So you have current speed, which is our starting point, to be 0, and current speed 10, 20. So it's with an increment of 10. And when you're at the 100, then you've reached your maximum speed limit. I hope that is clear. Another type of the flow control is the while loop, right? So for the while loop, let's just assume that you're driving your car and then you have a full tank, for example. Let's assume your tank is pretty much on the 100. Let's assume the level or the fuel tank is 100, right? Now you want to keep monitoring your fuel tank and make sure that when you are out of fuel, you get an alert for the out of fuel. This is what this is doing, right? So this particular line of code is saying, okay, I have my gauge of 100, right? But I want to keep driving. While my fuel level is still greater than 0, just keep printing the level, which means just keep telling me what I have while I'm still greater than 0. But if it is equal or less than 0, of course, definitely you want to print out this. This is what this line of code is doing. And pretty much while loop is used for continuous. I want to continue to do something until I've achieved my aim. That is what it's used for, okay? Let's just run this and just see what we've got, right? So almost the same thing, right? So here we have, okay, we have definitely the first one is 100 because we started with a full tank 100. And as soon as it negates by 10, which this is doing, it keeps, after it's print out the percentage of fuel we have, then it subtract a 10 from it. So it decreases by 10. And then you have fuel 90, 80, and 200 until we're out of fuel. I hope that is okay. Another type of control flow we're looking at is the do while loop. So for do while loop, let's just assume that we're going on a very long journey and we're driving a car to that journey. Before you go on that journey, you probably want to check your car at least once, right? If it works, you stop checking. But if it doesn't, you probably want to take it to the workshop and check it again and check it over and over again. So, okay, that is exactly what do while loop does, right? Do while loop will just check a condition one time. If that condition is met, it stops checking. But if it is not, then it keeps checking until maybe you throw an exception or something, or you just tell it to do something else, right? So let's just look at this. Let's put a debug point somewhere here so we see what this is doing. Let's just do a debug here. I know we've not gone into debug, but we'll do that, okay? Let's run a debug and see what this is doing. So in this code, you see we set a variable of engine, does engine works, and we set it as true, okay? And then we're doing a count of how many times we've done the check. So here, the increment here, what we're doing is, okay, do an increment when you do that check. Just increment the number of the checks and then print out, okay, engine, checking engine, then the check number. Of course, the check number is how many times we've checked it. And then there's a condition here that's saying if the engine is okay, which means if the engine is okay and the count is less than 3. Here you have a false here, right? If the engine is false and not true, because we have true here. So if you come here, let's just do a debug here and see. So maybe you would understand this. We already have check 1 because we're doing a one-time check. And then we come here and then we say if the engine is not true. Okay, let me explain this line. You have a not here, like an exclamation mark here, which means it is converting this particular engine, this true, into false. So it is saying if this engine work is false and the check is less than 3, okay, while it is less than 3, okay, but in our case it is wrong because it is true. All right, so we're not taking this condition into consideration at all because this is true and not false. Okay, so let's just jump over it again. See, because it is true, we're now printing out the engine is fine. But what if in a case where it is false and the engine is not fine? All right, let's just take a look at that. Let's just change this to false, for example. All right, let's change that to false and see what happens, and see how many times it's supposed to check 3 times, right? So let's just take a look at that and see. All right, let's do a debug again. Okay, good. So here we have the check, first check. We're doing the first check. Let's just jump over it. It's doing the first check, check 1, and then it goes here. It says false, and then it comes back again and do another check. All right, this is check 2. Okay, and then comes back again and sees a false because the engine is not working the first time and the second time. We then want to do a third check. All right, and then we do a third check, and then now we assume the engine is working, right? And then the engine comes back as fine. I hope this is clear now. All right. Another type of the control flow is the brake. If you remember, in the switch case we used the brake, right? What it does is it immediately exits a loop or maybe a switch as we used it the last time. So let's just assume that you're driving a car, for example, right? And you're checking for bumps on the road. Now, if you find a very big bump, for example, you just want to stop immediately just so you don't damage your car. So in this case, this is what that scenario is like, right? So for example, in this code we have a for loop. We've talked about for loop, and this is a classic for loop, right? We have a for loop, and we're saying that if you're going through that for loop and you get to the 5th bump, for example, you get to like number 5, just brake because I do not want to damage my car. All right, so that is what this is going to do. So again, this for loop is pretty much iterating over from 0, starting from 0 and ending at 10. But when it gets to 5, if I'm on 5, just brake because I don't want to break my car. Right, let's stop. So that's what this brake does. It exits a program. So let's just run this and see what we've got. Okay, so as I explained earlier, it exits. And what this line is saying is when it is on 5, just exit and give me, I stopped because I saw a big or a large bump and I just don't want to damage my car. Okay, so that is pretty much straightforward. Another one is the continue. All right, unlike the brake, in this case, what we want to do is, let's assume we're driving a car and we are just seeing potholes and we're saying, okay, as soon as I get to pothole 5, I just want to skip pothole 5 and then I want to keep going, right? So that is what this is saying. It simply means that when I'm on the 5th pothole, just jump it and keep going, all right? Don't brake, just keep going, all right? Let's just run this and see what it looks like. So here you have 0, 1, 2, 3, 4, and then it's skipping 5 because we want to jump pothole 5. We just want to skip it and keep going. And then we don't have 10 because we're saying less than 10. So, but if we do less than or equal to 10, then you should have 10, okay? And then, but it's still going to skip up the 5 because we're saying just continue. Do not print me 5. I hope that is clear. Another type of control flow is the return statement. Now, what the return statement does is it exits the current method and optionally returns a value. What does that mean? Let's assume we have a diagnostic workshop, for example, and we're just trying to check if our brakes or our cars are doing good, right? So let's just assume, let's be specific about the brakes, right? And then we're saying that we want to check the brake, and if the brake is functioning fine, just tell me, okay, yeah, all is passed, you're good to go. But if the brake is not functioning fine, return a log or a statement telling me that my brakes are not working properly, all right? So this is what this code is doing, all right? So here we have a method here, a private static string method, which means this is going to return a string. If you notice from our previous videos, we have a string. A string is always in a double quote and not a character. A character is in a single quote, all right? So I don't want us to mix it. And so this code is saying, okay, I have a boolean here, the keyword again, and a variable type, all right, that is set to false, okay? Now, if this particular brake is working, just tell me everything has passed. But if it is not, return brake is not working. Brake not working and stopping, right? Again, from the last time I explained that this means that not. Let's just run this and see. All right. So currently we have brake is not working. Then you're stopping. But what if we change it to through here? Let's just change it to true. Okay. And then it should tell us all has passed, because definitely, see, all check passed. All right. I hope you understand this. If you have any questions, please feel free to drop your questions in the comment section. Another type of control flow is the exception handling. Now, exception handling is a very, very big and broad topic, right? Now, for exception handling, we have different ones. We have the checked and unchecked. In subsequent videos, I would also be creating different exceptions, exception handlings. For example, I'll be creating custom exceptions. For example, that will be when we're creating APIs and when we're creating microservices and the likes. We will get there soon. But in this case, we'll be talking about the arithmetic exception here, which is one of the unchecked exception, right? Now, in the nearest video, again, we'll know why it is unchecked and why it is checked. But for here, we just want to focus on the control flow, which is at the arithmetic exception or the exception handling. Now, what we're doing here is we're trying to divide 100 by 0. Is it possible? It's pretty much an exception. It's supposed to throw an error. So, for example, imagine a car system, it detects an error and then just throws an alert to the driver rather than just making sure it stops, right? This is just that scenario. This is that case. I don't want my car to stop immediately. I still want to drive to where I'm going to, but tell me that it is faulty. That is this scenario, right? So we know that 100 divided by 0, it's supposed to throw an error. Do you want to try it? Let's just try it. Let's see if we're going to have an error or not. All right. Let's do this and just print. Let's just run this. Let's see first. Are we going to get anything? See, it throws an exception here. It says, let's see what that error is. The error is clear here. It says arithmetic exception, right? Divided by 0. You cannot do that. It's not possible. So how do you undo this scenario whereby you do not want to see this error and it's just gonna keep doing what it's doing? That is where exception handling comes into play, right? So let's just uncomment this and try this and see how this resolves our issue a bit. You see? So now, instead of throwing me an exception here, what it does is it then comes here and says, hey, your car is faulty, you need to fix it. That's what it's saying, right? Or cannot drive at infinite speed, or for example, right? So it just printing this. In summary, what this does, it makes sure that you still do something, you still throw an alert or something to say that the code is not running the way it's not supposed to run. There are really some more control flow types, but we will get into them as we go further. I know the theories might sound a little bit vague and blurry, but don't worry, as we go, you probably have more understanding of how all this work together. For example, in the nearest one, we'll probably be talking about the synchronized keyword, for example, which is, again, another type of the control flow. We'll be looking at a lot of things. The thread, for example, do not get scared. Java is broad, yes. It might look vague at a point, but as we go, you will get more clarity and understanding as we go step by step. Once again, I'm excited to be your instructor for this journey of building excellence. Please subscribe, leave your comment, click the notification button so you could see the new videos, and most importantly, I want you to share with your friends. And I'll see you in the next video.